Here is another example of oxidative cleavage. Oxidative cleavage is about breaking this bond in half, and instead of them being bonded to another carbon, they're bonded to oxygen. This can be done with ozone. The alkene reacting with ozone forms this product, ozonide. Ozonide is then reacted with dimethyl sulfide, and this gives the cleavage that we are looking for. And in this case, unlike in the permanganate example, the aldehyde is not further oxidized into a carboxylic acid, like so. It does not do that. So let's have a look at what's going on. The first thing that's needed to be noted is that ozone, here is the resonance structure, and it's important to remember that it does not really look like this. It's an average of both of these. Really, it's not a full double bond and a single bond. It's like a single bond and a half. So they're even. At one point, is not one oxygen have more charge than the other side. They are evenly distributed. It's just difficult to represent. This is how it is represented. So these are not full double bonds. As a result, they are more reactive, and they can react with alkenes. Here, the electron density of the alkene will be attracted to these oxygens. One or the other, they're both the same. When this begins to happen, a bond here, a partial bond begins forming. When that happens, this bond begins to break. When this bond begins to break, this electron deficient oxygen can withdraw these electrons. And at the same time, this oxygen will be able to bond to the other carbon. And it forms this intermediary product. But this is not a stable product, and it quickly rearranges. The oxygen over here is going to form another bond with the carbon at the same time as this bond begins to form over here. This bond is going to begin to weaken. The oxygen over here, it is slightly more it's not electron deficient, but the way it's sharing these electrons, normally oxygen is able to hug the electrons more to itself, but since it's competing with two oxygens over here, it's not got as much electron density as normally it would like. So as this is happening, this is what's causing the rearrangement. As this is happening, this oxygen in the middle is going to withdraw electrons from this oxygen over here. While that is happening, the oxygen, to make up for that, is going to form another bond with the carbon. So another intermediary results, carbon double bonded with oxygen and bonded with another oxygen, and a carbon double bond with oxygen. But it's going to rearrange and react with itself. This oxygen will react with the carbon over here. The oxygen on this carbon will react with this carbon and form this ozonide. After we have this ozonide, in order to get the oxidative cleavage to occur, it needs to be reacted with dimethyl sulfide. When this happens, we get the ketone, and here we can see the cleavage. And this time, the aldehyde stays. It is not further oxidized. And here is the ultimate fate of that extra oxygen. It is on the sulfur.